Hi, welcome to Chapter 6. Chapter 6 is one that's called Functions. We saw in Chapter 3 where we can call a module and we can pass that module different variables and we can receive those modules and we can modify those modules. And remember, we had this thing called pass by value and pass by reference. So if I had if I had a variable in my calling module that I needed to get updated by a called module, I'd have to make sure I pass by reference. Well, there's another way to do this. We can create a function that we call and then it will return a value. So that's basically what Chapter 6 is all about. So there's actually only 3 sections in here. So let's basically get into it. So let's talk about functions, and we're going to basically be creating or using a function called generating random numbers. Most all programming languages, whether it's Python or Java or Visual Basic or any of these different languages that are out there today, they all have a way to generate. They have a built-in function, I should say. So they have their own functions that we can call, and it will basically give us data back. In Java, there's one called math. There's a math function, and it has different, I should say a math class, and it has different built-in functions that will return things to us. For example, I can say give me pi, which is 3.14159. So basically whatever the big long numeric value is. So in this particular case, we're going to be talking about random numbers. I want you to give me a random number between the numbers 1 and 100, and it will do just that. It will bring back a random number. Could be number 1, could be number 42, could be 99, whatever the case may be. So the book calls these library functions. That means they are built-in functions in the programming language. So they're part of the programming language's library. So we give it input, it gives us output. Okay. So we have what's called the random function. And what it does is we've got our set statement. So in pseudocode, we use the word set to set a variable to something. And so I'm going to create, so I have a variable called number. Now I can't stress this enough. Before you use a variable, it has to be declared. The reason it has to be declared is we have to tell it what type of data is that variable going to contain. Again, if I have a numeric, I cannot put string data in a numeric value. We just basically cannot do that. So what we're going to do is, so we have a variable called number, and it's probably either a integer or a real. In this case, it's probably an integer. So I say set number equals, now random, now anytime we know we're calling either a module or a function, it's going to have that module or function name with parentheses. Okay, we always know that we're calling either a function or a module because it has parentheses. So in this case, we've got the random function, and it's got 1, 100. So those are the arguments. So the arguments we're passing, and the module or the function is going to receive those as parameters. So we pass arguments, it receives parameters. So whatever this function does with the 1 and 100, it's going to return a numeric value that will go into number. Okay, so so it looks weird. So I'm calling a function and it's returning something that's going to be put into this variable called number. Okay. Now what random does is we say I want to start with the number 100 and I want to go all the way to the number 100. So it basically will return a random number between 1 and 100. So I would declare integer number, set number equals random, 1, 10, display number. And the output, again, maybe a 7, maybe 42, maybe 56, we don't know. So here's the program. Declare integer number and counter. For counter equals 1 to 5. Set number equals random, 1, 100. Display number, and then basically end our for loop. So we're going to go do this for loop 5 different times. So again, we get back 89, 7, 16, 41, and 12. Again, is that what's going to be every time? No, it's a random number generator, so each time is going to be a random number. And then I could say display random 1, 10. I wouldn't even have to set it to anything. I'd just say display it. So whatever gets returned from that random number will be basically displayed. Okay. So let's take a look at this in the Spotlight. This is a good one to go through. So here it says Dr. Kimura teaches introductory statistics class and has asked you to write a program that he can use in class to simulate the rolling of dice. The program should randomly generate 2 numbers in the range from 1 through 6 and display them. In the interview with Dr. Kimura, you learn that he would like to use the program to simulate several rolls of the dice, one after the other. You describe to write a loop that simulates the roll of the dice and then ask the user to whether or not the roll should be performed. As long as the user answers yes or Y, the loop will be repeated. Okay, so here is the pseudocode. Declare string again, do, display. So this is a do loop with a while, so that means it's going to happen at least once. So it's a do while loop. We're going to do it at least once, and then we basically are checking the loop at the end. So we display rolling the dice. Their values are, and then we say display random 1, 6. Display random 1, 6. So the reason we called it twice is each one of those displays is a die that we are basically rolling. So we display, want to roll the dice again, Y equals yes, input again, while again equals Y, lowercase y, or equals an uppercase Y. So now we're getting to the realm where we are going to allow them to use either an uppercase Y or lowercase y. If either one of those is returned, that basically makes that while statement true. We're going to go back up and do the do statement again. Okay, so this is what the output should look like if this was a real program. Rolling the dice, the values are, again, we're getting random numbers between 1 and 6. We happen to get a 2 and a 6 back. So do you want to roll again? Y equals yes. We type in a Y. We roll the dice. Their values are 4 and 1. Again, it's not going to be 4 and 1. It's going to be whatever the random number generator returns. I can't stress that enough. Do you want to roll again? Yes. Rolling the dice, and the values are 3 and 3. You roll the dice again, enter, no, then enter, and it basically stops. So how that would look in pseudocode is this. Start, declare string again. We then display rolling the dice, display their values are, display random numbers 1, 6, display random 1, 6, display want to roll the dice again, Y equals yes, we input again, and then now this is when we do the check. This is a do while. So we're going to do these at least once, and we check at the end. If again is equal up lowercase y, or again is equal to an uppercase Y, if that's true, we come back up and we do those again. If anything but a Y is entered, we basically come out of the false end of that decision or that loop, and then we basically end the program. So here's another one, using random numbers to represent other values. So it says Dr. Kimura is also happy with the dice rolling simulator that we wrote. He asked you write one more program. He would like a program that he can use to simulate 10 coin flips. Okay, each time the program simulates a coin flip, it should randomly display either heads or tails. You decide that you can simulate the flipping of the coin by randomly generating a number in the ranges of 1 to 2. You will design a decision structure that displays head if the random number is 1 or tails if it's a 2. So very simply, we would declare integer counter. We have a constant integer num flips equals 10, and then for counter equals 1, 2 num flips. And we're going to basically do this for loop. If random 1, 2 equals 1, then display heads, else display tails, and if, that's our for loop. So all we're doing is just basically give me a random number between 1 and 2 each time. And if it's a 1, it's heads. If it's anything but a 1, it's basically tails. We display that, so the program might end, and we're going to do that 10 times because we're going to do it from 1 to num flips, which is a 10. And so we got tails, tails, heads, tails, heads, 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 tails, heads. Again, is that what it's going to be every time? No. The random number just randomly grabs a number. So it's like somebody sticking their hand in a hat full of numbers and pulling out a number. That's all it is. So how that would look in a flow chart, we have our start, we declare our integer counter and our constant integer num flips and set that to 10. Then we set our counter to 1. Now anytime we have a set counter equals 1 and then we have set counter equals counter plus 1, that's probably a good indication that that is a for loop. So it's always a good indicator for the flow chart that it is a for loop. So I come in, I've got num, while num counter is less than or equal to num flips, while that's true, we come in and check to see if the random function starting with a 1 for 2, if that's equal to a 1, we're going to display heads. Else we're going to display the tails. Then we're going to set counter equals counter plus 1. We come back up and check to see is counter less than or equal to num flips. If it is, we keep going through that loop, and then once that is no longer true, we basically drop out of the program. We hit the end. Okay. So that happens to be a library function. That's a built-in function that someone else wrote and we have access to. We're going to talk about writing our own functions now. And this is going to be very, very similar to chapter 3 when we wrote modules. We're going to see one major difference though. So a function starts with the word function instead of module. That's one big difference. Then we have a data type. Now the data type says what are we going to be returning. Remember our random function returned a numeric value. It returned an integer. So in this particular case, we need to make sure that this function, because we're going to make when we call that function, we're going to make some variable equal to the call to that function. So it has to call or has to return a specific data type, whether it's a string, whether it's an integer, whether it's a real. Whatever the case may be, we have to return a specific data type. Could be a Boolean. So we got the function name and then the parameter list. And then I've got any statements in there, and then the most important feature of a function. A function always has to have a return statement. If I have data type up here, if I have data type as part of the function line, I have to have a return statement. If I don't, it will not work. You will get an error and you will basically lose points on your homework if you do not. So functions always have a return, and we have our end function. What is this value going to return? It's going to be whatever data type is up here. Okay. So here I have a function. It's going to return an integer. Let me look at it down here. Here's bigger. So here's my function. It's going to return an integer. The name of this function is sum. Inside the parentheses, the parameters, it's going to have an integer num1 and an integer num2. So it's receiving two integers. Now, is it receiving those by value or by ref? In this case, it's receiving them by value. I declare an integer result. I set the result equals to num1 plus num2. Then I return result. Notice that result is an integer. It's declared as an integer. It's being returned as an integer. So whoever calls this function will be receiving an integer. So let's take a look at how this would look in a program. So here I have declare integer, first age, comma, second age, and total. So I have three integers, first age, second age, and total. I then display enter your age. I input the first age. I then display enter your best friend's age. I input the second age. So now I now have two variables, first age and second age. They have numeric values in them. I then set total equals, so here I've got my total variable. It's also an integer. I make that equal to sum, comma, first age, second age. So I come down here and here's my function sum. Notice it's got integer. That means it's returning an integer. It's called sum, which is what's being called, and it accepts integer num1, comma, integer num2. This, and up here it's basically passing first age and second age. It receives it as num1, num2. Again, since it's receiving it by value, it's receiving a a brand new variable that it just created called num1, num2. Whatever data was in that first stage and second stage is now put into num1 and num2. They're not the same variable. I then declare integer results. I just declared a new variable called result. I set result equals num1 plus num2, and then I return result. And since result is an integer, it's been declared as an integer, I'm returning an integer inside of the function line. Boom. Since it's a function, I have to have a return. So if I enter age 22 and I enter age 24, it then comes back, and up here it says display together you are comma total comma years old. So if I enter 22 and 24, it says together you are 46 years old. If we saw that in a flow chart, we would see sum integer num1, integer num2, declare integer result, set result equals num1 plus num2. Notice that in the module, in chapter 3, we just had the word return in there. Now we have return result. Okay. Notice we do not have anything up here in the declaration of the function. It doesn't say function. It doesn't say anything like that. It just says the name of this function is sum, and there's the 2 being passed in. But the difference being is it's got return and a variable. Okay. If we take a look at this sum, here I've got function integer sum, integer num1, comma integer num2, declare integer result, set result equals num1 plus num2, return result. It says notice that there are 3 things happen inside this function. 1, a local variable, result, is created. 2, the value of the expression num1 plus num2 is assigned to that variable, result. And 3, the value of result is returned. Okay, so a function is getting data, and then it's basically returning data. So again, big difference between chapter 3 and chapter 6 is that chapter 3, we called that module, it did stuff. Did it return anything? No. Chapter 6, we're calling something and it's returning something. Most programming languages allow you to create both modules and functions. Functions provide many of the same benefits as modules. They simply code, reduce, duplicate. Okay, which meaning if I have code that I keep doing over and over and over again, don't duplicate. Never, ever, ever duplicate code. Put it in a module or put it in a function. Because functions return a value, they can be useful in specific situations. For example, you can use a function to prompt the user for input, and then it can return the value entered by the user. Suppose you've been asked to design a program that calculates the sale price of an item in a retail business. To do that, we'd basically do the following. So I've got function real. So whenever I see a data type right after the name function, I know that it's returning that data type. The return statement will have a variable of that data type. So real, get regular price. Notice it's got parentheses but nothing in there, so we're receiving nothing. So I declare real price. I then display enter the item's regular price, and I input that price. And then I return price in function. So the only thing that this function is doing is it's all about displaying the input to the user, getting that price, and then returning it to the called module. That's all it's doing. It's doing no calculations, it's doing nothing. Its job is to do one thing, get data from the user. So here I could say set regular price equals get regular price, left and right parenthesis. Again, anytime I see a parenthesis, whether it has data in it or not, I know it's a module or a function. Okay, if I'm saying some variables equal to that called item, I know it's a function then. Set sales price equals regular price minus regular price equals discount percentage. So this is the calculation we need to do. So instead of doing that, I'm going to call a function to do that for me. So here I've got function real. Again, I know it's returning a real data type. Discount real price. So it's receiving a numeric value, which is a real, and it's returning a real. So it says return price equals, return price times discount percentage. Okay, so somewhere we have this discount percentage, or it's probably a global variable. Set sales price equals regular price minus discount regular price. So look at this. Here I'm actually calling the discount function right there. That's pretty cool. So set price equals regular price minus this called function that's going to pass at the regular price. That's pretty neat. So here's how the program would look all together. I have a constant real discount percentage equals 0.20. So that's a global variable. Every function or module within this program can see that, that global constant. So here's my module main. I declare real regular price comma sales price. Set the regular price equals get regular price. So I come down here to get regular price. So here is function real get regular price. It's passing nothing in. Declare real price. Display, enter the item's regular price, input the price, and then return price. So that's all. The only job of that function is to basically ping the user for a price, get it, and then pass it back to the calling module. So when I say set sell price, start regular price equals get regular price, it just basically called that function, got that value back. Then I say display the set sales price equals regular price minus discount, left and right parentheses. Again, anytime I see something that has parentheses behind it, that is a call to a function or module. And since since it's part of an equation, that means it's expecting something to be returned, I know it's a function. So I look down here at discount, and here is function real discount. Since it's got real, I know it's returning a real data type. Here's the name of the function, discount, and it's expecting a real numeric value that's going to be called price. It returns price times discount percentage. So when that comes back, it's going to be in sales price. Display the price, the sales price is, comma, sales price, and it displays the sales price. So we're now breaking this program up into modules and functions to make this more user friendly as far as basically maintaining. Okay, I can see the entire logic from main to end module. I can see the entire logic of the program right there. It says set regular price equals get regular price. I don't know what get regular price is doing, but I know that it's basically going to return regular price, and I'm going to have that variable set. Then it says set the sales price equals regular price minus discount with the regular price in there. So I know discount is doing something to the regular price and returning the sales price. So input output charts, we can basically see that would look like this. So here is get regular price function. It inputs nothing. The processing is to prompt the user to enter the item's regular price, and the output is the item's regular price has a real. Okay. The IPO chart for discount function, it would say input the item's regular price. Processing, calculate an item's discount price by multiplying the regular price by the global constant discount percentage. The output is the item's discount as a real. Okay, notice we have no coding in there. This is just an IPO chart. It shows what the input is, what the processing is, and what the output is. Okay. Okay, so in the Spotlight again, I want you to go through this one on your own. Make sure you got to get it, understand it, see what's going on. It says Hal owns a business named Make Your Own Music, which sells guitars, drums, banjos, synthesizers, and many other musical instruments. Hal's sales staff works strictly on commission. At the end of the month, each salesperson's commission is calculated to the recording. Less than $10,000, they get 10%. So $10,000 to $14,999, they get 12%. Now realize, if they have $12,000 in sales, they don't multiply the entire 12,000 times 12%. The first 10,000, and they get 10%. Anything over that, they get 12%. Same thing with the next. So let's take a look at the last one. 22,000 or more. So if they sold $25,000 in sales, 22 minus 25, they'd get 18%. Up to 21,999, so they take that. So between 18 and 21,999, I get 16%. So anyways, are they doing it way? I think. So pay equals sales times commission rate minus advance pay. Okay, take a look at that and basically really kind of follow it, get to know what it's doing, and basically have a good understanding of it. Okay. Returning strings. Here we have function string get name. Notice it's got string in there. That means it's returning a string. So whoever is calling this, I'm making that equal to a string variable. So declare string name, display enter your name, input name, and then return the name. Okay, simple as that. Returning Boolean variables. We can basically make a function have a Boolean as a data type. So it's returning that. So here is function Boolean is even integer number. So again, this is kind of one of those things where we want to make the function name something that can be used inside of an if statement that really makes that if statement really stand out. So in this case, it's got is even. I can say if is even. Wow, that really stands out, makes that if statement really easy to read. So it's going to return a Boolean. So first thing I do is I declare a Boolean called status. If the number mod 2 equals 0, so remember what mod does, it's the remainder you're getting back from a division statement. Okay, so whatever number was passed to this function, I'm going to divide it by 2, and the remainder I'm going to check against 0. So if I divide a number by 2 and I get a remainder of 0, I know it's even. So I set the status equals true. Else set the status equals false. I return status. So right away I basically have just returned true or false, depending on if a number is divided by 0 with a 0 remainder, or numbers divided by 2 with a remainder of 0. That's a great function to have. So now how do I use it? I say if is even number, then display the number as even, else display the number as odd. Well, look at that. All of that code right there is in that one line right there. I'm sorry, right there. That's as easy as it gets. So I'm passing a number, and it's going to return true or false, whether it's even or whether it's odd. Okay, so this last section talks about more library functions. So again, there's a lot of built-in functions, and when we talk about pseudocode, again, pseudocode is just us displaying English language that we are going to convert into a program, but we have to make sure we get our logic down and we do things properly in the proper steps. So we have a mathematical function. Here's a square root, SQRT. We're just going to assume that it basically works. Okay, so set result equals SQRT 16. Hopefully that's going to return the number 4. So here is declare real A, B, and C. So we got 3 variables A, B, and C that are real. Display into the length of side A, input A. Display the into the length of side B, input B. Set C equals square root A times 2 plus B. Is that B minus 2? Can't quite I'm sorry, set C equals the square root of A times A plus B times B. Okay, so then it says the length of the hypotenuse is C. Here's a POW function. Another common mathematical function is the POW function. The purpose of POW is to raise a number to a power. Okay, so POW would be 4 raised to the second power. That's 4 times 4. So we can either use the caret symbol to do that, or we can use the POW. So we've got ABS, which is an absolute value, COS, which is cosine, round, that's a nice one. If I give it round of 12.7, it's going to return 13. Sin, which is which is the SINE of an argument. I don't know much about algebraic expressions or not geometry, but anyways. So TAN, tan is a tangent of a number. Data type conversion functions, to integer. We're going to assume there's a variable or a function called to integer. I can convert a real to an integer. I can actually convert a integer to a real. So to integer, that means I'm bringing in a real statement, and that is returning an integer. And to real does the same thing. I'm receiving a real, and it's returning. I'm receiving an integer, and I'm returning a real. So here is a program. Declare real ounces. So I've got one real variable. Declare integer number of people. Constant integer ounces per person equals, is that 8? 8. Display how many ounces of lemonade do you have? Input ounces. So I have a variable called ounces, a variable called number of people, and a constant called ounces per person. I then input how many total ounces do we have. Then I set number of people equals ounces divided by ounces per person. Okay, so here is the error. I'm taking a real and dividing by an integer. I'm not allowed to do that. So I have to basically make sure whenever I do mathematical equations, they all have to be the same thing. So to fix that, I would basically do this. Set number of people equal to integer ounces. So it converts ounces, to integer, left and right parentheses around the entire equation. Ounces divided by ounces per person. It's going to get back a decimal number. It's going to convert that to an integer and put that into number of people. You can serve number of people. Okay, so in this case, I entered 165. It says you can serve 20 people. Formatting functions. Most programming languages provide one or more functions that format numbers in some way. For example, it might convert to a currency. Okay, so declare real amount 6,450 times 9879. Display currency functions amount, and that's going to return $6, 450.88. It automatically rounded that number to 2 decimal places. String functions. So a lot of programming languages have built-in functions for strings as well. A length function that will basically return the number of characters in that string. The append function allows me to append more string data at the end. So for example, I might have first name, or I might have name, and I've got first and last name. So I make name equal to first name, and then I say name.append last name, and automatically glues the last name to the end of that particular string. So here I have declare string last name Conway, declare string salutation equals Mr., declare first string proper name, set proper name equals append salutation comma last name. So basically glues those two things together. Notice that I made sure I put a space after Mr. period, because when it glues those two things together, so append is just gluing two things together. When I append those two things together, if I didn't have a space there, it would be Mr. period Conway, and it wouldn't look right. To upper and to lower, those are other two great functions. So I can take a string and say display to upper string, and it's going to have all of the characters in that string converted to uppercase. And vice versa with to lower, it will do just the opposite, convert everything to lowercase. Okay. So here I have do, display hello, display do you want to see that again, y equals yes, input again, while to upper again equals y, so whatever I get from again, I'm going to always convert it to an uppercase and then compare that to an uppercase y. So if you type in a lowercase y or an uppercase y, it doesn't matter, it's always going to convert it to an upper, even if it is an upper, and then check it to an uppercase y. I can do the same thing with to lower. That way there I don't have to do while again equals uppercase y or again equals lowercase y. I can have one statement. While to lower again equals uppercase y or lowercase y. Here's a substring function. Substrings are great because it allows me to take a portion out of that string. I can just take a portion out. So I can declare string str equals New York City. Declare string search. Set search equals substring. Now notice I've got str in there. That's the entire string of New York City. And I want to grab from positions, start at position 5 for positions 5 through 7. So if I go 1, 2, 3, 4, 5, with programming, we normally start with 0. So if I say start in position 5, that's really position 6. Because if I go 0, 1, 2, 3, 4, 5, that's starting with the O in York. And then position 7, 6, 7, so 7 would be K. So it's going to give me positions 5 through 7, which is really 6 through 8. So here I can say declare string name Kevin, display substring name 2, 2, which is going to display, so 0, 1, 2, the V, and end in position 2, which is V. It's going to return just the V. So here I have declare string str, declare integer numTs equals 0, numTs, declare integer counter. So I have a variable called numTs, it's got initialized to 0. I've got an integer counter, and then I display enter a string, input str. I'll string up here as well. For counter equals 0 to length str. So whatever we've typed in that string, we know the length because we can use this length built-in function. So if I happen to type in my first name Mark, that would be 0 to 4. Okay. If substring str counter comma counter equals t, uppercase T, then numTs equals numTs plus 1, end if, and then march the end of our for loop. So what we're going to do is we're going to start in position 0, go all the way to position 4, and each time we look at that position, because I'm using a substring to use the counter, so first time through it's a 0. I want you to go from position 0 to position 0. Bring that one character back. Is it equal to a T? If it is, add 1 to the T numTs counter. If it's not, we're going to basically loop back around because notice there's no else statement. So if that statement's true, we add the T's. If it's not true, we basically continue on. And then we display the string contains numTs instance of the letter uppercase T. So if they typed in 10 times I told you to stop and I hit the enter key, it says that string contains 5 instances of the letter capital T. There's also a contains function. So if I say declare string equals 4 and 7 years ago, declare string 2 equals double quote SEVEN, the word 7. And it says if contains string 1 comma string 2, then display string 2 appears in the string. So what contains does is it's going to look at the string 7 years ago and see if the string SEVEN is anywhere in there. If it is, it's going to return a true. So contains returns a true. So in this case, it would display string 2, which is the word 7. It would say 7 appears in the string. The string to integer and string to real functions. We have to be very, very careful with these because we're going to try to convert a string into a numeric value. So if I have a declare string interest rate equals double quote 4.3, notice it's got double quotes around, that means it is a string data type. If I want to use that now in some type of computation, it has to be converted to a numeric value first. So I would say set int number equals string to integer str. So 4.3. Now, what would happen with that? Since it's 4.3 and it's an integer, we're going to lose the 0.3. We would just get the 4. Or I could say set real number equals string to real str. So it's going to take that 4.3, convert it into a real data type, and put it into real number. Set int number equals string to integer 1, 2, 3 ABC. We would basically get an error. It would blow up and say, sorry, that is a non-numeric value. If I have set real number equals string to real 3.14.159, that would blow up as well because we cannot have more than one period or decimal place. We also have functions called isInteger and isReal. I can actually say if isInteger str set int number equals string to integer str. So I can in that particular. So again, it allows us to take a string data type and check to see, does it contain numeric data? What type of numeric? Does it contain real or integer? Okay, so in that previous example, we could basically say interest rate. I could have said right here, if well, I'd probably set that to a variable. Well, I could say if 3.14.159, or if I could say if is real, double quote 3.14.159 double quote, then go ahead and set real number equals to that string to real, else display a message saying that is a non-numeric data type. So it allows us to basically do that. So anytime you were to ever use string to real or string to integer, you'd always want to have that in an if statement that says if is integer, then string to integer. If is real, then string to real. Okay, so that's the end of that chapter. Again, functions and modules are very, very close. The big difference is a function always returns something, and we have to tell it what it's returning. So there's always going to be a return statement. If you have a function without a return, it will error out and you will lose points on your homework. So any questions, give me a call, contact me. I'd be happy to help you.